Hi there, Andrew Dunkley here, and thanks for joining us on another edition of Space Nuts. Lots to come today. We'll be talking about a meteorite that was discovered not recently. They've known about it for a few years, but they've made a discovery in regard to this one. It was found in the Sahara Desert, so we'll tell you all about that. It's got quite a fascinating backstory. And we talked about it recently, courtesy of an audience question, that of whether or not dark matter stars might exist. Well, now the James Webb Space Telescope is suggesting that there is one out there. Maybe more than one, but we'll be talking about that, potentially three. And we've got audience questions, a couple of left field questions from Scott, Mikey and Graham. We'll tackle all of that today on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to go on and on and on and on and on about all of that is a professor we know and love so well, Professor Fred Watson, astronomer at Barge. Hello, Fred.
Nice to talk to you again, Andrew. And I think we both can go on and on and on. And
we can.
Respected things.
I've been doing it for a living for 40 years. Yeah. Just going on and on and on about stuff. Yeah. Now, by the way, all well in your world?
Yes, thank you. Yes, we were down last week at Karula in South Australia, which is right at the northern end of the Flinders Ranges, and we were there because they have just been declared a dark sky sanctuary. So
fantastic!
A bit of a celebration that we were involved with, but It was very nice to visit. It's an extraordinary place geologically. It was widely prospected after the Second World War for uranium. There is uranium there. There is indeed a uranium mine there, but there's but it's a natural environment that is highly unspoiled, apart from the roads that lead to the uranium prospecting sites, which let you actually access some of the most extraordinary scenery I think I've seen in Australia. Remarkable. Yeah.
It's really good that you and Marnie can bring darkness to the world.
It's our mission. That's right. Marnie styles herself, because she is the Princess of Darkness, she styles herself a Lady of the Night.
Oh, that's lovely.
But that might mean something else.
Yes. Yeah, well,
she's not that.
With that one.
Am I a Lady of the Night? She says. It always goes down well in talks.
Yeah, I can imagine. Yeah. Oh, that's terrific. So that'll be making a lot of astronomers very happy.
Yeah.
All right. Well, let's get on to our first topic. And this is, as you mentioned, as we mentioned at the start, about a meteorite, this first story. This is a meteorite that they found in the Sahara Desert, a little while back, but they've been able to study it. And what's fascinating about it is that it's an Earth rock. So how can it be a meteorite? Well, therein lies the question, Fred, because that looks like it is the case, and it's a first of its kind find by the sound of it.
It's certainly the first that has had this idea that it might have come from Earth tagged onto it, and it's still, I suspect, it's still scientifically a debatable issue as to whether it did come from Earth, but the evidence seems to point that way. So what we're talking about is a meteorite. All meteorites have names. This one is called Northwest Africa 13188. Very glamorous name.
Yeah.
And I think actually it might be in a private collection. I'm not sure, but it's been analysed by geologists, as you would, because people, people who think they've got a meteorite usually want to go to a geologist to check whether it really is a meteorite. Because some of them are just stones, they're not. People say, I've got a meteorite here, but it's just a rock. It's very hard actually to identify them. Anyway, this one has been identified. It meets all the characteristics of the meteorite. It's clearly been heated on its outer surface, presumably by its passage through the atmosphere. But it's geophysicists in the French National Centre for Scientific Research, they are basically investigating this. And what has led to the idea that it might be the first known boomerang meteorite is its composition is very, very closely matching the composition of rocks in the Earth.
Yeah.
And it's what we call isotopes, the sort of exact atomic structure of the atoms that the isotopes match what we find on Earth. And there's some really interesting what you might call nuances to this, because yes, those isotopes are matching, but some of them their ratios, the isotope ratios, have changed a little bit. And so what these scientists are suggesting is that change has been due to the fact that this rock has been in orbit around the Earth and has been bombarded by cosmic rays, because cosmic rays are subatomic particles. They're in space, hence the name. We actually don't know the origin of some cosmic rays. A lot of them probably come from star explosions, but there's a sort of high energy background that has people scratching their heads.
Some of them are from Russia. I'm very aware of a cosmonaut named Ray.
You should save that for the dad jokes that we do on TikTok.
maybe I should.
What do you call a Russian? No. Yeah, never mind. Anyway, there's a suggestion that the isotope ratios have changed because of their bombardment by cosmic rays, and the amount of change leads these scientists to believe that they've been bombarded by cosmic rays for at least 2,000 years, and possibly more like 10,000 years. And so what that is suggesting, that this rock somehow came from Earth 10,000 years ago. Now, the candidates for an event on the Earth's surface that would send a rock into orbit, which would orbit for a while and then eventually come back again. The candidates are, first of all, a volcanic eruption, and we've had a very big one quite recently, the Hunga Ha'apai volcano in Tonga. Was it 2 years ago now? It's a while ago.
Yeah, it's getting on.
Yeah, that actually hurled rocks, but not into orbit. Apparently the debris that was emitted by that blast peaked at around 58 kilometers, 36 miles. And that's not high enough to get into orbit. You'd need to propel it higher and actually give it a sort of horizontal velocity of some sort as well for it to stay in orbit.
Yeah.
So these rocks went high into the atmosphere, but weren't high enough to actually become an Earth-bound or an Earth rock that is suddenly in orbit. So the other catastrophic or high energy event that they postulate, and they think this is the likely one, is an asteroid impact. Because an asteroid impact generates huge amounts of energy and can send rocks very high. In fact, it can put rocks into orbit. And we think that's why here on Earth we see meteorites from the planet Mars. There are some meteorites which are called Martian meteorites, which we know have come from Mars. And we know that because of the traces of gas that are entrapped in them, which match Mars's atmosphere exactly.
Yeah.
So I think there are about 300 Martian meteorites known now.
Okay.
They're classified into different types. So it looks as though what we might have is a scenario where something hits the Earth 10,000 years ago, or thereabouts, maybe a little bit before that, propels debris into space. Some of it stays in orbit. That orbit gradually decays, as orbits do, and eventually this bit of rock comes back through the Earth's atmosphere, gets heated again by its passage through the atmosphere, and turns up as a meteorite in northwest Africa, in fact in the Sahara.
Yes,
Sahara Desert, where it was found. So yeah, a really interesting story. I suspect that it's still a likely candidate for debate, this tale. But the person, the person who's leading this study is clearly quite convinced that that's where it came from.
And how long ago are we thinking?
Roughly 10,000 years.
Right.
It's we don't actually know where the impact the crater was. I think one of the things that this team in France have looked at is to try and find an impact crater that might actually fit the bill for that. But excuse me, these are the 10,000 years ago is quite young, and if it would, they reckon it would form a crater probably something like 20 kilometers wide or something like that.
Grief. Yeah, it would have to be a massive impact to cause that amount of velocity.
It would, that's right, exactly. And most of the craters that fit the bill on that are millions of years old rather than thousands. So there is a problem here, I think.
Yeah, it sounds like it.
Yeah, but it's still a really interesting idea, and it's still, even if it hasn't come from Earth, it's remarkable that its structure and composition match Earth rocks very well.
Either way, it's a fascinating story.
Yeah.
And I believe, if it is, though, an Earth rock that's been out into space and then landed back on the Sahara Desert, that's a first. I mean, it's probably not the first, but it's the first one we've found.
Yeah.
Haven't they also found Earth rocks on the moon? Did we cover that?
They found moon rocks on Earth.
Moon rocks on Earth?
Yeah.
I thought they found something on the moon.
They might. Not sure about that. Not sure about that. There's certainly moon rocks on Earth, like the ones we get from Mars. They're created by impact craters, or impact events.
Now, hang on, there it is, 1971. The Apollo astronauts found a chunk of Earth that they dug up on the moon. There you are.
All right. So
I thought I'd heard about that somewhere.
That's well done. Well done. Thank you. That's a really interesting one. Maybe, who knows? Maybe you've made a link there. These two things might come from the same event.
That's it. Oh, yeah. That could be interesting.
Yeah. I'll follow up on that because I didn't. I'd forgotten that.
Yeah. Wow. Okay. So, which Apollo did I say it was?
Well, if it's 1971, it's probably it would be 15. Wouldn't it?
Yeah, no,
16 was sort of 72.
Yeah, I could look that up too.
Anyway, it doesn't matter.
But no, look, it's definitely something worth pursuing, and I'm sure they're doing more and more examination of this particular meteorite to see if they can figure it all out. But fascinating story. The Boomerang asteroid, and if you want to read up on it, it's on the space.com website. Fred, we've got a live studio audience viewing us today through various outlets, Facebook, YouTube and Rumble. One of them is one of our regular listeners, Misty West, who's sent us a terrible dad joke. Geez, Misty, I thought we were bad. This is plain terrible. I thought about putting an observatory in my house, but the cost was astronomical. With that, we'll take a breath. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, once again, the James Webb Space Telescope is in the news. It's been sort of looking around going, oh, what's that? And that's how it sounds, by the way. And it has found something that we did discuss recently, thanks to an audience question about whether or not there could be dark matter stars. And we kind of debated it and thought, well, how can it be a star if it's dark matter? Well, the James Webb Space Telescope might have discovered not 1, not 2, but 3 of these weird things.
Yes, that's right. And we have to preface this by noting that this is entirely hypothetical.
Yes.
But the idea is that if you have, and particularly this might occur in the early universe where the density of dark matter was probably higher than it is now. If you have a star that is formed by the collapse of a cloud of gas and dark matter. And that's how we know that stars are formed that way. Normally, it's the dark matter that sort of concentrates the gas itself. That's how a galaxy starts. So you've got this web of dark matter that is left over from the Big Bang itself. That has gravitational pull, which attracts the hydrogen. Hydrogen comes together, clumps together. I'm doing all this with my hands. I hope
I can see that.
the listeners clumps together.
People with very good hearing would be able to hear you doing that.
Yes, they would. They'd have to have very good hearing indeed. But anyway, that clumps together and eventually collapses into a cloud, a highly dense cloud under its own gravity. The pressure goes up, the temperature goes up. It goes up high enough that you can trigger nuclear fusion, and then you've got a star. So, but what the hypothesis for dark stars is something that's a bit different. If you imagine a mixture of the hydrogen and the dark matter, and it's collapsing to form a star, you hope. But what happens is that as the dark matter is compressed, there is a hypothesis that dark matter particles can self-annihilate, so that they come together and they just disappear and produce, electromagnetic radiation, a bit like antimatter and matter.
Yeah.
And so what they're saying is, if that happens, if you've got this mixture of gas and dark matter that collapses, and it sort of wants to be a star, but the dark matter itself, just by its self-annihilation, is creating energy. So it's producing light and heat, and that stops the hydrogen itself becoming a normal star. So what you've got is this star that's in a way kind of frothy. It's being prevented from collapsing into a normal star by the amount of energy that the annihilating dark matter is producing.
Okay.
And so it doesn't become a normal star. So the suggestion is that it does become a star, but it's gigantic. And one of the numbers that's being bandied around is that a dark star could be 10 times the diameter of the Earth's orbit around the sun. So what's that? That's 300 million kilometers is the diameter of the Earth's orbit around the sun. So if you multiply that by 10, you've got 3 billion kilometers, which is a very, very big star indeed.
Yeah. Well, it'll be easy to spot.
Well, that's right. And in fact, that is the trick. That's why these scientists who've been using or looking at a survey produced by the James Webb Space Telescope, why they're excited by it, because they're going to be big and they're going to be bright. They actually could be a lot brighter just because of the size of them and the fact that there's still energy being created. So what the scientists in question have done, and I haven't said where they are, but I think I'm right in saying this is at the University of Texas at Austin in the US. So these are scientists who have looked through James Webb Space Telescope data, something called the Advanced Deep Extragalactic Survey, which is, I think, publicly available probably. And what they've looked for is objects that are very compact, but have the spectral signature of being a long way away. In other words, they're highly redshifted. And they found 3 candidates for that. It's really, really interesting. What you've got to do here, I think, is work out a way that you can differentiate between one of these dark stars, which are very large, and a compact galaxy, because a compact galaxy might also look like this at the distance that the James Webb Telescope is looking at. But they think they're seeing in the spectra of these things evidence that they're not galaxies that they're seeing, that they're looking at dark stars, and they would be the first candidates for such an object. If it can be proven, and this clearly is going to generate much more research, what you've got is something that might give us a few more hints as to what dark matter is.
Yeah.
That's always a good thing at the moment. Any ideas are good ones. Send your ideas on a postcard, please. Yeah, it's the dark matter is an elusive material. It would be fantastic to be able to shine some light on it, if I can put it that way, by means of these dark stars.
I think the only thing that bothers me about this is that dark matter doesn't interact directly with matter as we know it.
Mm-hmm.
And yet, if there are dark stars that are in existence, you've got a correlation between dark matter and real matter, and one's disturbing the other. So how can that be?
Because the only way that dark matter does interact with normal matter is gravitationally. It's the one thing. Nothing else. It doesn't sort of talk to normal atoms.
They can't shake hands.
They can't shake hands. They can't. Dark matter can't block the light of brighter things behind it because it doesn't interact with electromagnetic radiation. But the only thing it does do is generates gravity, and gravity, of course, is common to both dark matter and normal matter. And so that's the idea, that you've got a gravitational collapse of a mixture of these two things, real matter and dark matter, at a very high density. And that's the critical thing about this. They collapse to a high density so that you get some shining of the stars, but also shining of the dark matter itself because of the annihilation. It's a really interesting story, and one that I think could have ramifications. I think we should follow this one as it evolves, and we might.
Oh, absolutely. And I suppose the fact that they've found more than one makes it even more fascinating, because a lot of the time we can say, all right, we've found one thing, and that is a planet called Earth that has life, but we've never found another one, so we can't say definitively that life exists beyond that one example. But here we've got three potential candidates.
Yeah, that's right. So really quite remarkable. I mean, again, there's still the possibility they might turn out to be highly compact galaxies. But nevertheless, I think it's a very intriguing story.
It sure is. Well, keep an eye on that one, and I dare say it's going to spawn a whole bunch of audience questions, because it just seems to be the topic at the moment. Dark matter, black holes, dogs and cats living together. People really want to know about that stuff.
We've got that too now.
Yeah, you have, haven't you?
And they're nearly talking to each other as well, unlike dark matter and real matter then.
Yeah, but they're not touching each other.
Well, they did accidentally this morning. The cat still takes a very dim view of the dog, but
that's usually how it goes, Fred.
Yeah.
That's just normal Earth life stuff.
Yeah, and so maybe dark matter takes a dim view of real matter. Who knows?
Highly likely. All right. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying was a go.
Space Nuts.
We're shuffling along rather quickly today. We better slow down. But we've got a few questions. I'm going to hit you with the first one because it does dovetail with that dark star theory. This comes from Scott.
Kia ora, Fred and Andrew. Scott Curtin here from Christchurch, NZ. I have so many questions, but I'll start with these two. Could the reason dark matter doesn't interact with light or build structures is that it hasn't gone through the Higgs field? Maybe there wasn't enough Higgs to go around. Thoughts on that, mate? Also, what do you think about afterlife time? It took 14 billion years for this life, but felt like just now. When we're gone, it could take trillions of years, but we wouldn't notice it until the next life. Even then, we could end up in a 14 billion year structure. I could go on and on. But just your quick thoughts on an afterlife or time when we don't exist, how fast it travels. Thanks, Fred and Andrew.
Wow, that's deep.
It's very deep. Yeah,
it's very deep. Thank you, Scott. Hope you're well. I guess first up, the dark matter Higgs field scenario.
Yeah, it's a really interesting question. And I guess we would assume that dark matter is affected or influenced by the Higgs field. So the Higgs field it's like all things in this sort of subatomic physics. You can imagine it as a particle or a field, like a force field, and the Higgs field is the element which is represented by the Higgs boson, which, as we know, was found in 2012 by at the Large Hadron Collider.
This called God particle?
Yeah, it was. Not a good name, but it was.
No, probably.
So the Higgs field basically is what gives other particles their mass. And we do know that dark matter particles have mass because they have gravitational attraction. And so one would assume that they interact with the Higgs field in the same way that normal matter particles do. But like so many things about dark matter, this is something that may still prove to be wrong. It might not be a certainty. But my assumption would be that, yes, dark matter is bound by the effect of the Higgs boson, the Higgs field, in just the same way as normal matter is, just because it basically has gravitational attraction. It has mass.
Okay. That was simple.
It's easier than the next bit, though.
Yes. Afterlife time. Now, I've got to confess, Scott, I'm not quite sure where you're coming from here, but I saw Fred nodding.
Well, I'm kind of reading between the lines here as well from Scott. But I wonder if so Scott's point is that it's taken us 13.8 or 40 billion years for us to evolve. If you include the period when the elements were being made by nuclear synthesis within stars and all of that stuff. So he is saying, okay, we've got a planet full of sentient beings, conscious beings who can understand what time is, and we can look back 13.8 billion years and sort of see the history of the universe and understand how we got here. So I think what he's saying is, if we disappear as a species and there's no other sentient beings in the universe, which is possible and a bit spooky, the next time organisms like us evolve, will they notice that the universe, that might be trillions of years down the track, will they notice that? And I think the way I'm understanding this question is it goes to some other issues which are about, some people have argued that unless you've got consciousness, the universe isn't real. So that it's like that argument about the trees fall down in forests when nobody's looking, that sort of thing.
Well, if a tree falls in the forest and nobody's around, can you still hear it? That kind of thing.
Yes, yeah, that's right. So it's the and it goes back to quantum theory, where particles can exist in superposition. We know that things can be in many places at the same time and different states altogether until you look at them, and it's the act of looking at them, or basically making them interact with the outside world, which is really what he's saying. But it's that causes that quantum superposition to be broken, and you can see things in one place rather than many places at once. So I think part of this idea is okay, if there's nobody here to see the universe, does it really exist? So is the clock still ticking, or do we? Does the next set of sentient beings that emerge still only see 13.8 billion years in the past, because they don't know about the trillion years that's elapsed since we were there?
Yeah,
a really, really interesting question.
Fascinating and deep discussion, and you could go on for hours. And it sort of reminds me of a discussion we had some time ago about a theory that was put forward that our existence is basically because of our consciousness.
Yes.
That, we only exist because we've created this scenario, if we can call it that. And that's just too mind-blowingly weird
Turns your head, doesn't it? That's right.
Yeah, but the other thing I thought was, okay, we know the universe is 13.8 billion years old, and if we vanish and, it all happens again, will they who become whatever they become in the twinkle of time ahead of us know anything about the fact that we existed, or has it happened before?
Yeah, but that's right. They might not know that. They would know that the universe was older, though. That just by
yes, I suppose
because you can looking at the redshift and things like that, you can get the age of the universe.
Yeah, but it did prompt another question in my mind. When the Big Bang happened, did we in some form already exist, whether it was molecular or whatever? We had to be around at the beginning, didn't we, to be created, or did we get created by a consequence of the reactions that occurred thereafter?
Yeah. So all the bits that happen, well, in fact, you're right in the sense that okay, so we are mostly H2O. So 2/3 of what we're made of is hydrogen, and most of that came from the Big Bang. So your point is well made that we are Big Bangers. We've basically got atoms in our bodies that were created a gazillionth of a second after the Big Bang, because the Big Bang itself, the energies were too high for protons and things to form, but soon afterwards they did.
Yeah. Well, most of us are H2O. A couple of my mates are COH, but couldn't help it. Dear. All right. Thank you, Scott. I think you've opened up a can of worms. We're going to get a lot of people on this, probably on social media, having a bit of a chat about it, because I've noticed with social media that the theory of time is often debated. Some people say, look, we only made it up. Humans created time. There is no such thing. So it just goes on and on and on. Thanks, Scott. Let's move on to the next question from Mikey, who's been a semi-regular of ours.
Hey, Fred and Andrew. It's Mikey from Illinois with another asteroid question for you guys. Last time we had talked about, you guys had answered a question about, I would love to talk to you guys, but we did not talk in person. A question about nuclear bombs and asteroids. And it got me thinking, if we did send a bomb to redirect an asteroid, on Earth at least, the shock wave, I assume, would be what would redirect or, cause damage to something here. In Earth or in space, there's no air. So I guess I'm asking, what is the force that pushes the asteroid and sends it in another direction, if not air being pushed? I hope that makes sense, guys. And thanks for everything.
No worries, Mikey. I think with the DART test, it was kinetic energy, wasn't it? That
yes,
created
that's right.
change.
Yeah, it was, absolutely. But Mikey's right, actually, because when we talked about asteroid, the idea from observations that something like half of asteroids might be rubble piles. I don't know whether you remember that conversation.
Yeah.
And it turns out
conglomerates.
It turns out that they are more robust than solid asteroids. And so the thinking was, I think we talked about the idea that if you detonated a nuclear bomb next to one of those, they might be more resistant to being blown apart by the shockwave.
Yeah.
But Mike is absolutely right. There's a vacuum in space. It's not quite a vacuum.
It's a Dyson.
It could be, yeah. I think
I'm on a roll today.
You're on a roll, but I think Dysons are rather more than a vacuum, aren't they?
Here we go.
You can mop them with mops and all sorts. Oh, fantastic. Anyway, notwithstanding all that, we do get shockwaves in space because we see them all the time in
gravitational waves.
No, real shockwaves through the interstellar medium. In fact, in a way, we think that's why what triggers star formation is density waves, which are kind of shock wave. They're a wave passing through this rarefied gas in galaxies. But when it comes to a nuclear detonation, I suspect the medium might still be the very low density residual gas that there is in the solar system. But I'd really should look more at this, because it could just be the blast of material that is being expelled by the nuclear weapon itself. The fact that it's, there's a blast of material, and the radiation itself, because the radiation has a pressure, and the radiation that comes from, and by that I mean electromagnetic radiation as well as subatomic particles, that's all going to effectively impact the asteroid. I would like to follow up a bit more on that, Mikey, because you've raised an interesting question there. So I'm going to put an asterisk next to my nose and find out about just what the mechanism would be when a nuclear bomb is detonated next to an asteroid. Why is it going to shift its orbit?
Yeah, it's a good question. I wonder if it'd be the same as setting off a bomb underwater. Is it a similar concept?
Except, you do have a very dense medium there that you want to interact with. So
yeah, water is pretty dumb. Okay.
Good thing it's there, though.
There's definitely. Speaking of pressure, and this is a sort of a side note, but I've been on the radio the last few mornings, and I've been keeping an eye on the barometric pressure.
Yeah.
When I was a kid, they used to refer to very high barometric pressure as an anticyclone, but you don't hear them say that anymore. But this morning, while I was on air, I looked at the barometer, and it was 1,041. And I thought, that's really high. I've never seen it that high. So we did some searching around, and one of my audience members sent me a link to the Bureau's, some Bureau data, which indicated that the highest barometric pressure ever recorded in Australia was 1,042. The highest ever recorded in the world was in Russia in 1968, which was 1,082, which is extraordinarily high. Yeah. But I thought, I don't remember ever seeing the barometer hit 1,040 in Dubbo, where I am, in all the time I've been reading weather, and that's, 20,000 years, 20-something years. But 1,041 is what it hit this morning. That just blew me away.
We are certainly sitting in a high-pressure region.
Yeah.
I'm going to be very rude and go and see what my barometer says right now.
Okay, well, that's not rude. Let's find out. Because but the interesting difference I noticed was that, because I was looking at the weather station information on the roof of the radio station. We've got a weather station right on top, and we're on top of a hill as well. So we're a little bit higher up than the airport. And the airport reading, even though it was high, at Dubbo Regional Airport was 1,036.6. So there was quite a difference between the two, which is hard to explain because the lower you're down, the lower the pressure, I think, or is it the opposite? I don't know.
Sorry, what did you do? 1,037.
So that's high.
Yeah, it is very high. And mine's sort of corrected for sea level. I don't know whether yours is true.
Don't know.
If it's not, then it's even higher because you're
at 267 meters.
Yeah.
Well, the radio station would be a bit higher than that.
Yeah.
The airport reading was what I was telling people when you stepped out was 1,036.6 this morning in Dubbo. I mean, it fluctuates. It's never constant. It's always
that's right. It was going up and down. Yeah.
But I thought 1,041 was way up there. Quite amazing. Just wanted to mention that, by the by, because we're talking about pressure and all that kind of thing.
Yes, great stuff. I love that.
All right.
Yeah.
We've got one more question. This comes from Graham. This one's a little bit out of left field, Fred.
Hello, it's Graham from London. I like your podcast a lot. Listen to it all the time. It's fair to say I'm a fan. I've got a quick question. Do you think it's possible for a planet that evolves life and there's a watery surface on a significant amount of it to evolve into a giant planetary eyeball. Thinking of, mushrooms linking plants together over enough billions of times, water, plants in the water uniting and everything like that. I know it sounds silly and it sounds clearer in my head than it does when it comes out of my mouth, but there could be giant planetary eyeballs in space staring across the vast emptiness. Yeah. I think that's clear. Love the show. Keep going. And hello, everybody out there. Thank you. Bye.
Thank you very much, Graham. He poses a fascinating theory as to whether or not a life form could grow to a point where it became an eye, the size of a planet or something to that effect. We do have massive life forms living on Earth, and I'm not talking about blue whales, but there is a particular forest, the name of which escapes my mind at the moment, that covers thousands of square kilometres, and it's technically one plant that's just spread itself out. So it does, he's not being silly. This can happen, at least in that form, but could it go to another level?
Is the Great Barrier Reef a single organism as well?
It is classified as the biggest organism on Earth, I believe, but But it's made up of lots and lots and lots of little creatures.
Yeah. Whereas the forest is just one.
Yes, it's one plant.
Yeah.
And I think there was another story I read where I think it was a fungus that was also quite massive that was found somewhere in Europe, I think, and covers quite a huge amount of ground. That might be the one I'm talking about that's thousands of kilometres. The aspen tree, I think, is the one that's got, it's about 8 kilometres long. I mean, that's probably an example of what he's alluding to.
So the Earth, so a planet like the Earth, even if it's covered with water, 100%, it's got to have a rocky core, and so in the sense that imagining a physical representation of an eyeball, it's never going to happen. That you've got something that's hollow, or at least filled with a fluid that's light transmitting. So you're always going to have a rocky ball with something on top of it, and in the Earth's case, it's water. In the case of many other objects, it's water with a layer of ice on top. Yeah. So they are common. And whether you could have an organism that arranges itself in such a way that it actually becomes light sensitive, and I suppose maybe a better analogue might be a fly's eye, because a fly's eye is lots of little lenses that are coated on a spherical-ish surface, each one out with its own receptor. Maybe something like that could evolve on the surface of the Earth.
That would be interesting. Yeah. Very interesting. It's a great question. It would make an awesome science fiction story.
Yeah, there you go.
Build that into it.
There's an idea for you.
I woke up last night trying to think of a new angle on a science fiction story, but I've got other projects going on at the moment.
Oh, yeah, that's right.
Not ready to write a new one yet. Got to tell you a funny story, though. I got an email the other day from Amazon.
Right.
Now, 2 years ago, I released the Hitler paradox. And when I did, they wrote to me and said, look, we're not happy with the cover. It's, it's got a swastika on it, and we don't publish hate symbols. Can you provide us with another cover? So I did. They published it with the original cover anyway. So,
oh, really?
Yeah, they did. And so I thought, well, okay, that was your call.
Yeah.
Well, last week they emailed me again and said we've, our quality control systems have picked up that you've got a swastika on the cover. We will not be offering this book for sale in Germany as it contravenes German law. And I said, well, fair enough. And I wrote back and said, you are the reason this has happened, because I did offer you an alternative cover and you didn't use it.
Yeah.
The reply was, our quality control people have noted that there is a swastika on the cover of your book. And I wrote back and said, well, can I upload the alternative cover again? And their reply was, our quality control people have noted there's a swastika on the cover. I tried one more time and said, can I change the cover? Our quality control people have noted there's a swastika on the cover and will not be for sale in Germany. I thought, are they using AI to deal with people? Because it can't be human. And if it is, not worried about the Terminator ever happening, because it's a pretty dumb AI that answers the separate inquiries with exactly the same phrase over and over again. Dumb as a box of hammers. Anyway, I'm going to keep trying. It's been fun. Thank you, Graham. Lovely to hear from you, and a really interesting angle on that theory. And if you do have questions for us, please pipe them through to us. Use some PVC and just roll it up in a piece of paper and send it our way. Or use a vacuum tube. You need a really big one, but it'll get here eventually. Or you can go to our website and send us a message that way. Pretty easy. spacenuts podcast.com or spacenuts.io. There's a couple of ways you can send us messages. And we look forward to hearing from you. I'm sure we'll get plenty more. And while you're there, have a look around. Don't forget about maybe looking into becoming a patron. And we send a big shout out and thank you to all our patrons. We have many, and it is greatly appreciated. It keeps the lights on. In fact, I blew a light the other day, and I'll have to get a new one. Just about to go to the shop and get one. So thanks for covering that for us. Fred, we're at the end of the show. It's been a really fascinating journey today.
We've had some great questions and some great topics, haven't we? It's always good to explore the limits of, first of all, the limits of what I know, which are relatively narrow, but maybe the limits of what science knows as well.
Yes, indeed. All right. Good to catch up, and we'll see you on the next episode.
I hope so, yeah. Yeah.
Okay, thanks, Fred.
I'll be miffed if you have somebody else on instead.
Not a problem there. Thank you, Fred. Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio who got up early for us today, but we were 5 hours late. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.
And we're out.
Excellent.
We will be in a second after it says stopping.